In this video, we want to be able to say that I can identify reflections, translations, and rotations, and also I can calculate the coordinates of the vertices of images after reflection, translation, and rotation given the coordinates of the pre-image. First thing we want to do is define what is a transformation. A transformation is a function that maps a figure, which we call the pre-image, onto a new figure called the image. A transformation can change the position, size, or shape of a figure. So we start off with what's called the pre-image, we end with what is the image. After the transformation is done, we have our image. What we start with is called the pre-image. A transformation can be notated using an arrow. The transformation statement, triangle ABC, goes to triangle XYZ, tells you that A maps to X, B maps to Y, and C maps to Z. So if we look at our picture down below, we have this triangle ABC. That is our pre-image. That is what we start off with. In a rigid transformation, also known as a congruence transformation or an isometry, the position of the image may differ from that of the pre-image, but the two figures remain congruent. Main thing you need to know is that if it's a rigid transformation, like what's above, they will be congruent, meaning that the shapes are the same size. There are three main types of rigid transformations. First off is a reflection, then translation, and lastly rotation. A reflection is also known as a flip. It's a rigid transformation over a line which we call the line of reflection. And we also know that each point of the pre-image are the same distance from the line of reflection. So with this image underneath, we can say that point C is the same distance from this line, which is the line of reflection, as F. These are the same distance. B is the same distance from that line as E. And A is the same distance as D is from this line. A translation or a slide is a rigid transformation that moves all points of the original figure in the same distance and in the same direction. In other words, A goes to X the same distance that C is going to go to Z and B is going to go to Y. They will move the same exact distance. A rotation or turn is a rigid transformation around a fixed point called the center of rotation, through a specific angle and in a specific direction. Each point of the original figure and its image are the same distance from the center. So A is the same distance to this point where we are rotating it around as M. B is going to be the same distance as N. And C is going to be the same distance as P is away from the point of rotation. In this example, we want to identify the type of rigid transformation shown. Is it a reflection, translation, or rotation? What we notice about this figure is that if we took each of the vertices and went down a certain amount and went over this a certain amount, we will see that each vertex is going to end up in the same spot. In fact, if we go down by 9 and over by 10, we will see that we end up in the same spot as if we went with this vertice. If we went down by 9, over by 10, it's the same location. If we go down by 9, over by 10, we end up in the same spot. Down by 9, over by 10, we will end up with the same shape. So this is a translation. In fact, the way we will notate this translation is -9, 10. And we are going to use a notation with these pointy parentheses. For option B, we notice that if we look at each vertex and compare it to the origin, the center of the graph, we will notice that they are the same distance. So that point is going to be the same distance. This other point is same distance to the origin, same with this point. And lastly, this last point. So this is a rotation. We're going to do some more of this example. Notice with this option A, it's a rotation again. So each of these vertices are rotating around the center of this graph. So each of these vertices are going to be the same distance as the vertices they relate to. In option B, this is a reflection. Notice that they are a mirror image. In fact, if we were to drop a vertical line right here, the line of symmetry, we notice that each vertice is going to be the same distance to that line as a vertice on the other side. So this one is going to be a reflection. In this set of examples, we want to identify the type of rigid transformation as a reflection, translation, or rotation. We're told that Maria looks into a mirror while brushing her hair. The image she sees has the same size, shape as her face, but it is flipped backwards. Well, looking in a mirror is a type of reflection. In part B, a delivery truck driver drives a straight 5-mile east without turning, carrying the same load from one warehouse to another. The truck's position changes, but its orientation stays the same. Well, because a truck starts in one spot and just continues on this way, going east, and does not turn, does not rotate itself in a new orientation, we know that this is going to be just a translation. And lastly, in part C, a Ferris wheel lifts riders in a circular motion around its center point. Each seat stays the same size and shape, but changes its direction as it goes around. This right here is a rotation. This is because we have our center point, and we have, as it rotates around, it's going to be the same distance as it's going around that center point. So this would be a rotation. In this example, we want to consider a triangle ABC. Find the coordinates and graph the image after a reflection across the x-axis. Okay, so we want to do a reflection across the x-axis. The rule that we have for reflecting across x-axis, the x values are going to remain the same, and the y values are going to be switched from being positive to negative or from negative to positive. So point A is at -8, 3. Let's list out the rest. Now, since we have our points listed out, let's see where they're going to go with our image. We're going to use prime notation to notate the image of this. So A prime is going to end up to be -8, -3. B prime is going to be 2, -5. And C prime, the image of this point, is going to be -5, +3. It changes your y value from being a negative to a positive or positive to a negative. Now let's graph this. Notice with our graph that these are the same shape. It's just reflected across the x-axis as if the x-axis is our mirror. In this example, we want to do the same thing, but we want to do this across the y-axis. The rule for the y-axis is very similar to the x-axis, except for the x is now the -1, the y is now the one that stays exactly the same. We want to reflect it across y being our mirror. So let's list out our points. Now, since we have the coordinates of our pre-image, let's find our image. So A prime is going to end up to be 3, 0, because the x value changes from being negative to being positive, and if it was positive, it would change it to be negative. B prime will end up being -7, 2, and C prime is going to be 0, -6, because 0 is neither positive nor negative. Now let's graph this. Notice with this graph, with this figure, that C and C prime are the same point. So notice that if it's on the line of reflection, it does not move. Also notice that A is the same distance to the y-axis as A prime, and B is the same distance as B prime. In this example, we want to do the same thing, but this time we want to do a translation, and we are going to use the vector style to notate a translation. The rule for translation is that if we have an x, y, and we want to translate it a distance of AB, we just take the x value and add it to A, and take the y value and add it to B. So let's get the coordinates of each of these points. Now, since we have our coordinates, let's find the x values. Take our x value and do the operation. We have a plus -2. So A prime is going to be at -11, positive 10. B prime is going to be at -1, 11. And C prime is going to be at -8, positive 4. Now let's graph this. Notice with these two shapes, they are the same figure, it's just moved. They are congruent. All the side lengths are the same, all the angle measures are the same, so these are congruent. This is a rigid transformation. With this example, we want to do the same thing, except for we want to do a rotation by 180 degrees. And with this rotation, we are going to rotate it around the origin, meaning the center point of the graph is our point that we are rotating around. Here's some rules that we have. 90-degree rotation going counterclockwise, so going this way around the circle. We are going to have the rule being we're going to put our y value, make it negative, and put it up front, and put our x value in the back. If we want to do a 180 rotation, whether it's clockwise or counterclockwise, this is going to be a negative x and a negative y. That's our rule for this one. And if we want to do a 270-degree rotation going counterclockwise, by the way, that's 90-degree rotation going clockwise, this is going to be a y value up front and a negative x behind. So let's get our points. Now, since we have our coordinates of our pre-image, let's find the coordinates of the image. So we want to do a 180-degree rotation. So we're going to use the rule in the middle. So to find A prime, we just change our x value to be negative and our y value to be negative. Remember, if it's negative, make it positive. If it's positive, make it negative. So A prime is going to be at 6, 0. B prime is going to be at the same spot. We're rotating it about the origin. It does not change. That point is the origin. And C prime is going to be 4, 6. Remember, if it's negative, change it to positive. If it's positive, change it to negative, and leave your x's and y's alone. Now let's graph this. Notice that B prime is the same because that's our center of the graph. That's the point we're rotating it around. Notice A, it's a straight line from A to A prime. That's 180 degrees. C to C prime is also a straight line. That's 180 degrees. Also remember that this is a rigid transformation, so these two triangles are congruent. In this example, we want to do the same exact thing, except for we're going 270 degrees instead of 180. I already have the rules listed out, and we are going counterclockwise. Double check on that to make sure that our rules line up. So let's list out our points. We are going to be using this last rule, which is to change our y value and put it up front and take our x value and put it in the back. So A prime is now going to be 5, positive 4. B prime is now going to be 4, negative 6. Take the y value in the pre-image and put it up front in our image. Take the x value in our pre-image and make it a negative or positive in the image. And C prime is going to be negative 3, negative 3. Now let's graph this. Now, since we have it graphed, notice that these are the same shape. They are congruent. So triangle A, B, C, we can say it got mapped to triangle A prime, B prime, C prime. And that is doing a rotation 270 degrees counterclockwise.